Hey, how's it going everyone, and welcome to another episode of Weekly Code Quickies, your weekly updates for tech news, coding, tricks and tips, and more. As always, I'm your host, Norbert BM, and in today's episode, we're going to discover what blockchain is. So come with me on this journey and let's dive into it. Now, blockchain is relatively new, but also not new. Though it's considered part of the big Web 3.0, it's actually pretty old. So together we're going to discover today what blockchain actually is, how does blockchain work, do you really need blockchain, and is blockchain secured? So what is blockchain? Well, the most simplest definition would be that a blockchain is a chain of blocks that contain information. A more complex explanation would be that a blockchain is a distributed database that is shared among the nodes of a computer network. The blockchain database stores information in digital format. Blockchains are best known for their crucial role in cryptocurrency systems such as Bitcoin for maintaining a secure and decentralized record of transactions. One key difference between a typical database and a blockchain is how the database is structured. A blockchain collects information together in a group known as blocks. It holds sets of information. Blocks have certain storage capacity and, when filled, are closed and linked to the previous block, forming a chain of data known as the blockchain. All new information that follows that freshly added block is compiled into a newly formed block that will then also be added to the chain once filled. A database usually structured its data into tables, whereas a blockchain, like its name implies, structures its data into chunks of block that are strung together. This data structure inherently makes an irreversible timeline of data when implemented in a decentralized nature. When a blockchain is filled, it is set in stone and becomes part of the timeline. Each block in the chain is given an exact timestamp when it is added to the chain. Cryptographer David Chump first proposed a blockchain-like protocol in his 1982 dissertation. Then, in 1991, Stuart Harbert and W. Scott Stornetta went to implement a system where document timestamp could not be tampered with. But it wasn't until 2009 where Satoshi Nakamoto described and implemented the first digital currency called Bitcoin using blockchain. So how does blockchain actually work? Now, a blockchain is a distributed ledger that is opened to anyone. Once data enters the ledger, it cannot be changed. The goal of the blockchain is to allow digital information to be recorded and distributed but not edited. In this way, a blockchain is the foundations for immutable ledgers or records of transactions that cannot be altered, deleted, or destroyed. This is why blockchains are also known as distributed ledgers technology or DLT. The components of a block are as following. It has data, a hash, and the hash of the previous block. Now, for the data, the type of data that can be added to a block depends on the blockchain network. For example, in the Bitcoin network, the type of data in a block is as following. From who has the information been sent, to who is the information going to be sent to, and what amount was sent. So each block has its unique hash. The hash is calculated and assigned upon creation of the block. If any kind of data would be changed in the block, then the hash would also change. This results in a totally different block which does not match with its previous block. For example, let's imagine we have 3 blocks. Each of them would have a unique hash. Furthermore, in addition to its unique hash, each block would also have the hash of the previous block. This will always prove its origin. Now, accepting the very first block in the chain that has only its unique hash but no previous hash, single exception here is the very first block. This only has his unique hash and no previous hash of any kind of previous block because it is the very first block. Now this block is called the Genesis block. But is blockchain really secure? Couldn't someone just hack the block and change the amount of Bitcoin that was transferred? Well, it's not that simple. And here's why. To begin with, new blocks are always stored linearly and chronologically, and they are always added to the end of the blockchain. After a block has been added to the end of the blockchain, it's extremely difficult to go back and alter the content of the block unless a majority of the network has reached a consensus to do so. Now that's because each block contains its own hash, along with the hash of the block before it, as well as the previously mentioned timestamp. So let's take the previous example again. Let's imagine again that we have 3 blocks in the chain. The first one is the Genesis block, with its unique hash, as we know. The second one, after it is created, gets also his unique hash, but additionally to the hash itself, it has the hash of the previous block, of the Genesis block, for example. And then comes the third block, and so on and so on. Now let's say that someone would try to change something in the second block. For example, the amount of Bitcoin that was sent. This would result in a new hash for the block number 2, which could then raise suspicion for the block number 3, saying, hey, wait just a minute, my hash does not appear to be the same with your hash. So what gives? Because the hash of the block number 2 and the previous hash of the block number 3 no longer match, and because the data has changed, a new hash was now created for the block number 2. Now block number 2 would now be considered invalid and would be discarded from the chain. But the simple hash validation is not enough in this age of supercomputers that could recalculate all the hashes in milliseconds. This is why most of the blockchains have an initial security on them, and that is proof of work. Now, proof of work is at the core of the system that manages Bitcoin transactions and secures the network. It does this by slowing down the time. Proof of work is a consensus mechanism used to confirm that network participants called miners calculate valid alphanumeric codes called hashes to verify Bitcoin transactions and add the next block to the blockchain. It does so by having other participants in the network verifying that the required amount of computing power was used by the miner that is credited with calculating the valid hash. By having this mechanism in place, the networks assure that no one tampers with the block. Now there is also a third mechanism in place, and that is decentralization. So let me explain. When a new user wants to join the blockchain network, then he is added to the peer-to-peer network. In a peer-to-peer network, a group of computers are linked together with equal permissions and responsibilities for processing data. Unlike traditional client-service networks, no devices in a peer-to-peer network are designed to serve or to receive data. This also means that when a user is part of the network, he receives a complete copy of the ledger of the so-called blockchain. This also means that when a new block is created, all of the users, aka nodes, are alerted and ask for verification and must give their consents. Only then will the new block be added blockchain. Do we really need blockchain? Don't we already have banks and systems in place to transfer money? Because cryptocurrency is digital money and we already have digital money. Each time you swipe your card, it's actually digital money. From its creation, more and more use cases are appearing for the blockchain technology. The most common one is sending digital money, aka cryptocurrency, extremely fast to places that don't have easy access to banks. What they are actually focusing on is the reduction of friction, reducing cost for each transaction. And this is how it works. A new transaction is entered. The transaction is then transmitted to a network of peer-to-peer computers scattered across the world. This network of computers then solves equations to confirm the validity of the transaction. Once confirmed, to To be a legitimate transaction, they are clustered together into blocks. These blocks are then chained together, creating a long history of transactions that are permanent. And then the transaction is completed. The more recent creation is, of course, the smart contract, which can be medical records, taxes, loans, mortgages, rents, and even more complex ones. But more on this on a later episode. So in conclusion, a blockchain is a chain of blocks that include insightful information. Every block contains records of the data, its transaction, and timestamp. This process is closely related to blockchain's decentralization distribution chain that allows proved users to access data all at once. That's it for me, everyone. Hope you enjoyed this episode. If you did, give it a like or leave a review depending on where you're watching or listening on. Also, share it with others because sharing means caring. And if you are not already subscribed, then please consider doing so because we release new episodes on a regular basis. And if you don't wish to miss any of them, then click on the notification icon. And with this being said, catch you on the flip side. Bye bye.